Hello and welcome. So we're looking at a intersection of chords and radii there. So first off, we are given a couple of lengths in our circle. We're given that the diameter of the circle is 15.4, and we're given that the length of the chord from T to H is 12.4. And then we're asked to solve for x, where x is that little distance there from D to the chord right there. So in order to find that, the main thing that we really have was we have something awesome working for us, right? If we see a right angle here, that means that the angle right here is also a right angle. And why that matters is that now you have a right triangle, which is awesome because we know that for any right triangle, if you have a right triangle, you can use what's called Pythagorean's theorem, where for any right triangle with legs A and B and hypotenuse C, if you add the legs that are squared, you'll get the hypotenuse squared. And this will allow you to solve for any length. So I'd say, alright, so from here, now I would say, alright, well, if we know that the diameter is 15.4, that means that how can we just find part of it, right? Well, part, specifically meaning half, that half is just going to be 15.4 divided by 2. So that's going to be 7.7. Because if we take half of the diameter, we find the radius. And likewise, if we know that this, we have a cool property with chords, getting way too many colors there. We have a cool property with chords that whenever you have from center outward, right, intersecting chord at the right angle, it's we have something that bisects the chord. Now that just means that it cuts the chord in half, meaning that that length is the same as that length. So that means that 12.4, if we take half of that, we get 6.2, and that is the length of each one of those sections of the chord. And now you have enough for the right triangle, right? We have one leg, here's the other leg, so we do 6.2 squared plus x squared equals your hypotenuse, 7.7 squared. And that's it. Now you have the setup. Solve for x, right? So if you want to get x by itself, you want to subtract this 6.2 quantity squared from both sides. 6.2 from both sides, so we get, bam, that'll cancel, and we get x squared equals 7.7 squared minus 6.2 squared. Okay, and now this just becomes some calculator work right there. So it's alright, so let's find out our 7.7 squared is, right, and we get 59.29, right, our 6.2 squared, whoops, not 62, 6.2. So then all we do is we end up subtracting those values. So 59.29 subtract 38.44, and we end up with 20.85. So that x squared equals 20.85. Now, how do we finish solving for x? Well, x is squared. We undo a square with a square root. So then we get x equals the square root of 20.85. Now, remember that whenever you take a square root, you have both plus and minus, but, right, we're talking about an actual physical length. Can physical lengths be negative? No, right? So it's only going to be the positive square root of 20.85. And that's another just calculator job, right? So then we do square root. Oh, whoops. Of 20.85, and we get 4.566, and back, so 4.566. And that would be it, right? It says if needed, go to the third decimal place. We did, right? And if you double check that the digit after that 6 is a 1, and the 1 will round down. Alright, so be careful around it there, but suffice to say, we've done everything we need to, right? We've found our missing distance. That's all it's asking us to do. Okay? Not too shabby. Thanks for watching.